page is going to help us understand why we see color a little bit better. So it says, for each object, think about the primary color that you see, and then use that color to analyze how light is reflected to fill in your chart. So I have listed a bunch of different things down here for you: banana, grass, a stop sign, a blueberry, car tires, snow, a pumpkin, or an eggplant. All right, and I want to know the color that we see. So that's going to be the wavelength that is bouncing back in our eye, to tell our brain what color the object is. And then I want to know what colors we don't see. So what colors are being absorbed into the object. So for example, this highlighter right here, hopefully we can all tell that it is orange. I'm seeing this as orange. This is the primary color that I'm seeing, an orange wavelength. But you got to remember, there are many other wavelengths in the visible spectrum. So there is red, yellow, blue, green, violet, indigo, all those other ones that I'm not seeing. So I would put down that I see the orange wavelength, and red, yellow, green, blue, and violet are being absorbed into this. That way I can't see it. That way I only see orange. So let's try a banana first. Hopefully we all know that a banana is yellow. So the color that I see, the one that is bouncing back into my eye, is the yellow wavelength. Therefore, since the yellow wavelength is coming back into my eye, that means all of the other wavelengths are being absorbed into it. Just like how with this post-it note right here is yellow, I'm seeing yellow. That means yellow is coming back into my eye. It's being reflected back into my eye. However, the colors red, blue, green, orange, those are being absorbed. That way I don't see them. So the colors being absorbed by the object would be red, orange, not yellow, because yellow is coming back at me. So red, orange, then we skip and go to green, blue, indigo, and violet. So everything other than yellow is being absorbed. So grass. Hopefully we all know grass is green. That means green is coming back into my eye. That means that red, orange, yellow, not green, because green's coming back at me. So blue, indigo, and violet are being absorbed. That way I don't see them. All right, a stop sign. We know that a stop sign is red. So that means the red wavelength is coming back into my eye. So I see it as red. Therefore, the orange, the yellow, green, blue, indigo, and violet are being absorbed. That way I do not see those colors. All right, a blueberry, well, this even says it in the name. A blueberry is blue. Therefore, red, orange, yellow, not blue, because blue's coming back at me, but I need to put green. Red, orange, yellow, green. Blue would be next, but it's over here coming back at my eye, being reflected. So red, orange, yellow, green, indigo, and violet are being absorbed. That way I don't see them. Car tires. What color are car tires? If you think about it, car tires are black. Well, black is not a color in the rainbow. So what do you think? I told you yesterday, think about when you go outside in summer heat and you're wearing a black hoodie, black pants, black hat, and maybe black shoes, and you get super, super, super hot. Okay? That is because the color black absorbs all colors. So technically, black is not a color. Black is the absence of color. Black is what happens when there is no color and there are no wavelengths coming back into our eye. Black is basically nothingness. There's no wavelength coming back at my eye. Therefore, I see nothing. I see just black. All right. So Black is what is bouncing back in my eye. That means nothing is bouncing back in my eye. That means all of the colors are being absorbed. That's why you get so hot if you wear black in the sun, or that's why the road gets so hot in the summer. And if you walk on the road with bare feet, you're going to burn your skin on your feet because it gets so hot. It absorbs all of the wavelengths, so it takes it all in. So red, orange, yellow, green, blue, indigo, and violet. I'm going to put all right there because all of the colors are being absorbed for something that is black. All right. What about snow? Hopefully you know that snow, oh my gosh, I almost wrote the word snow. Snow is what color? Hopefully we know that snow is white. Well, this is kind of weird too. Snow is white. Well, white is not a color in the rainbow. But we talked about this yesterday too during the lab. Remember, I said if you wore all black clothes and went outside, you'd get super hot because black absorbs all of the colors. But white is when all of those colors are coming back into my eye. So if I take the colors red, orange, yellow, green, blue, indigo, and violet and put them all together, that would be kind of like looking backwards through a prism. We know that if we look through a prism, the white light is refracted into the rainbow. But if you put a rainbow into a prism, what do you think is going to come out the other side? White light. So colors that are being absorbed by the object, none of the colors in the visible spectrum are being absorbed because that means that all colors are coming back into my eye so that I see white. So think about this. I know it's a weird concept, but white is me really seeing all of the wavelengths, and my brain can recognize when you see all of those wavelengths put together, it's white. But black, the color black, is when I see no wavelengths coming back at me. It's the lack of color. There's nothing there for my eyes to pick up on. That's why it shows it as black, because all of these wavelengths are going into the object and I see it as black. Okay, but here all of those wavelengths are coming back at my eye, and my brain recognizes that when the whole entire rainbow comes back at my eye, it is white. All right, let's do the next one. Pumpkin. Hopefully we know that that is orange. So orange is coming back in my eye, therefore everything else is going into the pumpkin. That way I see that the pumpkin is orange. Just like how I talked about this highlighter here is orange. Therefore red, yellow, green, blue, indigo, and violet are all coming back at my eye. Or no, they're not coming back in my eye because this is what's coming back in my eye so that I pick up that the pumpkin is orange. I see orange wavelengths. My brain knows the wavelength of light is orange, and that's why I think a pumpkin is orange. Same thing for this. Same works the same way. Lastly, we have an eggplant. And if you don't know what an eggplant is, it's a vegetable. It kind of reminds me of a squash, but it is purple. Well, hopefully we know that purple is the same thing as violet. So I'm going to put that also. Okay, so that means that purple is coming, the wavelength of purple, the shortest wavelength of light is coming back into my eye, and that recognizes, or my brain recognizes that as purple. That way I can tell the eggplant is purple. Therefore, that means the eggplant is taking in all of the other wavelengths so that my brain knows this wavelength is purple, and that's what color an eggplant is. So red, orange, yellow, green, and blue and indigo are being taken in, absorbed by the object, so that way I know the purple can come back at my eye. So red, orange, yellow, green, blue, and indigo. All of those are being absorbed. So also, I'm going to write here, I'm going to highlight this. bounces off the object. That way I can see it. And over here, I'm going to put absorbed by the object. That way I can really tell the difference. All right. So remember, when you're looking at something, you're seeing whatever wavelength is bouncing back at your eye. Okay, and all of the other wavelengths that are in light are getting absorbed by that object, so that way you pick up on that specific color. Except I'm going to take a colored pencil that I have, and I'm going to draw a star next to snow. And I'm also going to draw a star next to car tires. And the reason I'm doing that is because car tires and snow, those objects are different than everything else. Not just saying only car tires and snow. I'm saying anything black or anything white is different than everything else because black absorbs all the colors. It's the lack of color. I'm also going to write that right here. Lacking color. Technically, black is not even a color. It's the lack of color. And the color white, that's when all of the colors are coming back in my eye. All of those wavelengths. That way my brain recognizes it as a white light. All right, so hopefully your page looks like mine. If you need to pause it and rewind to get yours to look like mine, totally do so. All right, now you are going to see these pages here on Canvas on the next page. This is going to be your test. All right, you can use your notes. That is why we spent time taking these notes to help you with your test. All right, please take your time. You're also going to see this page as your test, but it's going to be digital for you. All right, so please take your time. Make sure that your notebook looks like my notebook because I am going to be checking it on Monday. So please make sure that you make yours look like mine. And I will see you in the next video. Bye.